Did you have a chance to make your guesses? If not, go ahead and pause the video so you can have a chance to. Okay, on the left, you can see there are more hydroxide ions than hydrogen ions. And so that's the definition of a base. This is going to be our basic solution. Here in the middle, what do you notice? I hope you see an equal number of hydrogen ions as hydroxide ions. This must be our neutral solution. And just picture this positively charged hydrogen ion attracted to and bonding with this negatively charged hydroxide ion. What will they form when they bind together? Water, right? H2O, there it is. And water, of course, is neutral. Okay, lastly, we're left with a bunch of hydrogen ions, right? They outnumber the hydroxides, and this will be our acidic solution. Okay, great job. Now, I'd want to review this pH as an inverse logarithmic scale before we do some practice with it. So pH is a measure of the concentration of hydrogen ions, and it is inverse, meaning opposite. So as the concentration of hydrogen ions increases, the pH decreases. Something with a pH of 1 has more hydrogen ions and is more acidic than something with a pH of 2. But how much more? That's where the logarithmic part comes in. Each step on the pH scale is actually a difference in a power of 10 or 10 times more or less hydrogen ions, depending on which direction you're going in. So, for example, how many times more acidic is a solution with a pH of 4 than a solution with a pH of 5? And if you said 1, you know it's more acidic, that's good, but you're not remembering this logarithmic part. The answer is 10 times or 10x more acidic because each step is 10 times difference. And so I hope you begin to see that a small change on the pH scale will make a big difference, especially if we're talking about things that live in aquatic solutions. Let's do a little more practice. Now we're going to look at gastric juice, your stomach acid, compared to your urine. Okay, so stomach acid is here with a pH of 2. It's more acidic than urine with a pH of 6. They're both acids, they're both acidic, but stomach acid is more acidic. Well, how many times more? Well, it's 1, 2, 3, 4 steps away on the pH scale. But remember, each step represents a change in 10 times. So it's 10 times 10 times 10 times 10 more acidic. 10 to the fourth or 10,000 times more acidic than urine. And this is why if you've ever thrown up before, you've felt stomach acid come up your esophagus, it burns, it feels terrible. Now, maybe while we're here on this chart, you can take a look at some of the things you tested in the lab or some other things you might be interested in knowing about the pH of. Rainwater differs a lot from pure water, differs a lot from seawater. Okay, the last thing I want to talk about before we do a little more practice is that we can write these